Hi guys, so we are group 6 and we are going to report the orthographic views with dimensions and section view. So my name is Raymond Madali and I'm the first reporter. So first, what is orthographic projection? So orthographic projection is commonly used method in representing three-dimensional objects. Sometimes it was also called two-dimensional drawings. Before anything else, kung may two-dimensional, syempre may one-dimensional as well as zero-dimensional. An example of zero-dimensional is a dot. Just imagine it, a dot. It doesn't have any dimension, so it is zero-dimensional. And an example of one-dimensional drawing is a line. So just imagine a line. It has two dimension. It has one dimension. And examples of two-dimensional drawings are or shapes are circle, triangle, square, rectangle, pentagon, ganon. So let us move on. Each of the object is viewed along parallel lines that are perpendicular to the plane of the drawing. So for examples, an orthographic projection of a house. Typically, a house consists of a top view. So on the top view, what we usually see is the bubong, di ba? If it's pang mayaman, they have the roof deck. Just kidding. So that was we usually see on a top view of a house. And on the front view, we could typically or usually see a front door, of course. And on the side view, on a typical house, we could see a room windows, mga ganon, di ba? So, here's another example. So, orthographic and isometric projection of an object. I think this one is a buzzer or a button. So, here we have the top view. Obviously, on the top view, it's just a flat surface and it consists two shapes, a square, a rectangle and a circle. And on the front view, we could see a little bit of dimension because it consists of like two layers of something. And on the side view, it was the same as the front view. It's just a smaller version. And on the three-dimensional isometric projection, we could see all sides. We have the top view, the front view, and of course, the side view. So, parang pinag-isa kung tatawagin natin. So, ang three-dimensional or ang orthographic projection, it is an all-in-one view of all the parts in projection. Another one is this one. It shows object which its front, top, and right side orthographic views projected from the object. The views are two-dimensional, so they show no depth. Note that in the projected right plane, there are three rectangles. So on the right plane, yes, you can see there are three rectangles. You cannot identify kung ano yung mas malapit and kung ano yung malayo diyan na shape or rectangle. And on the front plane as well, we couldn't identify kung saan dyan ang malalim or saan dyan ang malayo, and as well as on the top plane. Diba? When we mix them all together, we could create the one in the inside, which is the object. It was three-dimensional. Okay. Next one. Okay, so this one as well. Show three orthographic views of a book. So, as you can see, we have the front view, the right side view, and of course the top view, which consist the leaves of or pages of the book, and the front view, which is the cover of the book, and the right view, of course, the same as the top, but it's just vertically shown. And then the next one is the section views. Okay, when we say section views, it is created by defining an imaginary cutting plane or planes on the object so that the observer can see the internal details. So it is just like a kuan. It's just like a floor plan. It's just that floor plan is horizontally viewed. Unlike the section views, it was vertically viewed. Based on my research, section views and floor plan should be connected to each other. Dapat may correlation sila. Whenever you make a floor plan, make sure na meron ka ding section views. It was supposed to be viewed vertically. So, parang skeletal ng isang bahay. Dapat kung anong nilagay mo doon sa iyong floor plan, it was meant to be connected with the section views. Okay, they improve visualization of designs, clarify multi-views, and facilitate dimensioning of drawings. Hence, they are important aspects of design and documentation. Okay, so here's an example. So this object shows a three-dimensional view. So we could see a front, a top, and a side view. So we are talking about section plane or section line. So paano nga ba natin makikita ang section line or ang section ng isang object? So in order for us to see the sections of a particular object, we need to use a cutting planes. In engineering drawing, we call it cutting plane line. So a cutting plane line is used to define the location of the section view. Kung makikita nyo, may nag-chat. So, as I was saying earlier, ano nga ba ang purpose ng cutting planes? Or nasaan nga ba dyan yung cutting plane? As you can see in the object, yung nandito sa left side, we could see na mayroong parang square or pa-square shape dyan na something in the middle. So, ayun yung tinatawag nating cutting planes. Diyan natin makikita yung loob ng object. Pag tinanggal yung kalahati nung nahati ng cutting plane, we could see the section line, which is yung nasa right side. So, material to one side of the cutting plane is removed, exposing the section view. So, doon na natin makikita yung section view. So, another example is a cake. So, di ba ang cake, hinahati natin siya vertically. So, once we cut the cake, we could see the inside of it. We could see every layers of that cake, kung paano ginawa, kung ano yung mga nilagay inside it, para magkaroon ng ganoong object. Okay, so next one. So, it shows the same object presented in figure 4 to 41 using two orthographic views and section view. So, dito naman, hindi na siya 3-dimensional. So, we could see it na as 2-dimensional. Pero ito, ayan. So, yung cutting plane, ayun yung AA. Vertically cut. So, ayun, na-reveal or na-unveil yung dimensions or yung section view or sections sa loob ng object. Okay, all surfaces directly visible must be shown in a section view. In figure 443, the back portion of the object is not affected by the section view and it is directly visible from the cutting plane. The section view must incline these surfaces. Note how the rectangular section blocks out part of the large hole. No hidden lines or hues on the section views. So, doon, dito sa ating right side. So, ayan. Kung makikita nyo, paano yan siya hinati. Or kung i-assess ninyo, paano yan siya hinati. Ano dyan yung natanggal and ano dyan yung views. Or yung view na makikita sa section AA. Well, walang sasagot. Siyempre, recorded. Anyway, so ayun, makikita niyo doon sa arrow, pag tinanggal or sa section line or sa cutting plane. Yes, kung makikita niyo sa cutting plane, it was represented with dash, di ba? Ayun, hindi siya actually straight line, dash yung ginamit. So doon sa dash, doon sa A to A, may arrow. So ikakat mo yon. Okay, so imagine na nakat na. So pag nakat na yan siya, ngayon, ang view niyan, or kung, in order for us to see it the way how it looks like sa representation dito sa right side, nakaano siya va? Dito, ano va? Oo, tama yung view. It's just that you are facing from here and the object is in front of you. Parang nakaganyan ka, day. Oh my God, it's very hard to explain it. But, yeah, pag natanggal na or ngayon, ang makikita mo dyan is a square, a rectangle, and another rectangle, and a square. And then, kung makikita mo, yung bilog doon na malaki, or the large hole, mayroong square doon, which is, na-block niya yung, hindi naman half, yung parang mga 2/4, mga 1/4 ng hole. Mga 1/4 ng hole. Ayun, na-block niya.
So, I am going to discuss this cutting plane line. A cutting plane is represented on a drawing by a cutting plane line. This is a heavy, long, short, short, long kind of line terminated with arrows. The arrows show the direction of a view. So, engineers use cutting plane lines on the plans they are drawing up to differentiate what is inside an object and what lies outside it. So, the cutting plane line bisects the object and provides a view of its interior features. So, the cutting plane lines and the interior features of the object they bisect are never in the same color of the rest of the plan. So, how cutting plane lines are created? Engineers may manually draw cutting plane lines on their design by using a paper, pencil or pen, a straight edge, ruler, or T-squares. Today, most cutting plane lines are done electronically, with engineers using computer-aided design to create them. Once again, here is a graphic example of a cutting plane line and the section that develops from it. So these are the examples. The example number 1 is the object. Number 2 is the cutting plane line. And the number 3 is resulting section.